Size of operator in C. So size of operator is most common operator in C. It is used to compute the size of its operand. It returns the size of a variable. It can be applied to any data type, float type, pointer type variables. When size of, actually even if we are saying it is a size of operator, it is actually a library function. When size of library function is used with data type, it simply returns the amount of memory allocated to that data type in bytes. In bytes, actually it is in bytes. In bytes. The output can be different on different machines, like 32-bit system can show different output, while a 64-bit system can show different for the same data type. So you already know integer takes 2 bytes, floating point takes 4 bytes, and I told you in some computer it will differ. In some computer it may take 4 bytes, floating point may take 4 bytes, and double may take 8 bytes. It may vary based on the computer. So to understand that, or to understand that value, we are using the size of operator. So size of operator is to get the size of a particular data type in bytes. I will illustrate with the help of an example. After that it will be clear. Already written the example, so no need to type the program. So we'll only some 10 more minutes. Where is that? Okay, don't confuse by seeing the length of the program. So we will discuss line by line. Okay. Here the statement is printf %d/n size of k. What is k? Is the program visible? Is the program visible? Please respond.
Yes, sir.
Okay.
Too small, sir. Zoom into more.
Okay. Is it enough?
Yes, sir.
Okay. So printf %d/n size of k. What is k? K is an integer data type. So it will display how many bytes are required to store the integer. How many bytes are required to store the integer in this computer. That means in my computer. So it is 4. So integer takes 4 bytes in this computer. So it may vary with the different architecture. Okay. Varsha Shibu,
Yes, sir.
what will be the output of line number 23?
2.
2. No, it is also 4 because already k is an integer. The size of k is 4. So similarly, size of int is also 4. So in some computer it will be 2. So in my computer it is 4. Sham Santosh. Sham Santosh.
Yes, sir. Yes, sir.
What will be the output of line number 24? Okay, I will just execute the program. The output is 1. Character takes 1 byte. So in every computer, character will take 1 byte. That you have to study. So it will not change based on architecture. Character always takes 1 byte. Similarly, I will print double, float and double. Float will take 4 bytes, double will take 8 bytes. Float will take 4 bytes and double will take 8 bytes. So listen, line number 27, size of IPTR. IPTR is a pointer. Pointer contains address. Pointer contain address. So I'm just printing it. So it is actually 8. It is 8. So the reason is in 64-bit computer, the size of pointer will be 8. In 32-bit computer, the size of pointer will be 4. Some of you may using 32-bit computer, 32-bit operating system. So there you will get the output 4. So always remember, in 64-bit it will be 8, in 32-bit it will be 4. Here I am printing CPTR. CPTR is actually a character pointer to character. So anyway, it is also storing some address. Here there is no difference in integer and character. Since it store address, if it is 64-bit computer, it will be 8. If it is an 32-bit computer, it will be 4. So again, 8 is the output. Next one. CARR. So I have defined a character array of size 10. I have defined a character array of size 10. Debug.
Hello, sir.
What will be the output of line number 29?
Is it character 1 അല്ലേ?
What will be the value?
1 അല്ലേ?
So character having 1. What is here? Here CAR is an array. How many characters are there?
10.
So how many space will be allocated?
10 space will be allocated.
10. So 10 bytes will be allocated. Okay, very good. 10 bytes will be allocated. Then Alex,
Yes, sir.
what will be the output of line number 30? What is IARR?
It's an integer.
It is an integer array. What is the size of a single integer value?
4.
4. Here how many integers are going to store? How many? 10. So what is the total size?
14.
40 will be the total size. So I got 40. Okay. Only few more steps are there. Printf %d/n size of S1. Size of S1. Okay, what is S1? X1 is the same structure we have defined. So what will be the size? So how many bytes are required to store name? Ankur Jaiswal. Ankur Jaiswal. Agnel Jose.
Yes, sir. Yes, sir.
Agnel Jose, what will be the output? What will be the size for this one? To storing 10 characters?
Sir,
How many bytes?
char 4.
Char is 1 always. In every computer, character will take 1.
Yes. So
So
10.
this will be 10 bytes.
Yes.
So in my computer, integer is taking 4 bytes. My computer, integer is again taking 4 bytes. So total of 18. So 1 minute. Maybe 1 minute. Okay. So total of 18. So what your expected output will be 18. 1 minute. Give me 1 minute. Hello. I am in class. I already told you, and I cancelled your call almost 5 times. I already told you now. There is no problem in understanding things here. Okay, what my expected output is 18, but I got output as 20. So in structure, it is not getting output as we expected. So it will have different calculation. So in the below I have given a link. In the link it is given in detail how to calculate size of each member for structure. So anyway, it is not necessary for you. So if anybody need more clarification, you can visit this link. Then next one, printf percentage d size of all. So what is all here? All is a union. So in the morning session we have studied, the initial period of this session we have studied what is union. So here we already saw, so I'm just making a change here. I'm writing double. So in the same program we already saw the size of double is actually 8 bytes. Size of double is actually 8 bytes. Size of double is actually 8 bytes. So in these 4 we already know, carry is 1 we already know, double is 8. So what's the specialty of union? So here what will be the size? Varada?
Yes, sir.
So here I have a union called mixed. Inside that I have 3 member variables. Size of each member variable is 4, 8 and 1. So what will be the total size?
You allow same the store.
No, everything will be stored in same memory. That is correct. So what will be the size of the memory?
Size remember.
Okay. So anyway, what Varada told is correct. Everything shares the same memory, and we can store only one data at a time. So in union, the size will be always the size of largest data item. Size of the largest data item. 1 minute. I will go through that slide, and it will be more clear. Here you just read this point. The amount of storage allocated to union is sufficient to hold its largest number. Or largest data type. So here double 8 is the largest data type. So I'm executing the program. I got the output as 8. Only 2 more things are there. Just only we have studied a new data type called void. So always remember, or all computers, the size of void will be 1 byte. Size of void will be 1 byte. But the interesting thing is, when I declare some variable void star p, when I declare some pointer void star p means it can hold an address value. To store an address, we need some space. So we already studied for a pointer, it is in this computer it is showing 8, and some other computer or in 32-bit system it may be 4. So even though the type is void, this p will produce the output 8. This p will produce the output 8. So it is 8. So understand these differences. Size of void is always 1 in every computer, it will be 1. Similarly, size of carry is 1 in every computer. But size of the pointer will be 8 if it is a 64-bit computer, and it will be 4 if it is a 32-bit computer. Okay, that's all I want to discuss today. Any doubt in today's session? Any doubt?